All right, this video is all about how you can design a simple residential building, how you can construct your general arrangement, which we call GA, how you can hinge, and why do we hinge, how you can load your walls, how you can erect your proper residential structural building. So if you're that one person that needs this particular building, you have difficulty or you're finding it difficulty to get to understand the design and the concept, then it means that this video is for you. So today we'll be looking at a simple residential building here about a two-bedroom flat because we just want to keep this video as simple as possible. First of all, you're going to have the dream maker, which is the architect. The architect is supposed to send you a particular design or the artisans or wherever you have a drawing plan. But in general, what you need to do is just to start off by analyzing and studying the plan. Why did I say so? You have to study the plan because you look at it, we have the ground floor and the first floor, and as case may be, because we want to keep this simple, we just have only a floor above the building. But in numerous situation, you can have as many floors as you like, maybe down to 20-story, and as the case may be, maybe there might be difficulties or changes in the plan, in the elevations, and how the shape of the building, how the building might look. Okay, but in today's video, we're looking at a very simple residential building because we want to start small for the beginning because this video is for the beginners. Hello. So looking at this structure, you can see from the plan, you look at the staircase, which is where we're going to introduce our void. And from our former video, I introduced some other step of which we are going to use to get a GA. But in this other video, step one, we're looking at how we're going to do our GA. So for you to do your GA, first of all, what you're going to do is just to set out your layer, because we'll be needing a layer for the column and a layer for the line, okay, which we're going to take it to the product structure or uh, any structural software you're going to use, because the structure is going to see the grid and is going to see the column, which means at any point where you have your column and where you have to intersect your column, your slab, and your beam, it means you're going to introduce your grid. Okay, so in this area, what we will need to do here is to introduce our grid, and also we're going to introduce our columns before we export it down to the product structure. We don't just want to introduce take our drawing down to the product structure before doing anything. So we just want to keep it simple by coming here and do a proper play, then we export it down to the product structure. With that, it's fast and safe. Okay, so in doing that, what we're going to do is just to go to the layer. If you've not created, in this my scenario, I've already created the layer, but maybe if you're starting a fresh design, what you need to do is to come over here by layer manager and you create a layer. We'll have layer, we'll have degree. I believe you have basic knowledge about AutoCAD, all right? But in our previous, in our recent video, we'll be talking about more. In our next video, we'll be looking at how you can do use your AutoCAD frequently for those that don't really know how to use AutoCAD, that really want to start from scratch. All right, so in this, if you come to the layer property manager, what you do here is just to come and create, then you label. We need to create a label for a layer for the column, and we'll create another layer for grid. But in this situation we have, so I will just close, then I'll go to start it. So what I want to do here is I want to start by doing what I want to start by creating the grid. So okay, you can see here, if I click on the grid, so I'll start by creating the grid over here, and everything, mind you, should be what by layer. So all your property layer should be by layer. All right, so introducing it by layer, then we'll come over here. What we need to do here is to get the middle of this point. Now I don't want to use each of these because I don't know where I can get my center line. You can see because of this line over here. So what we need to do here is to get a linear line. If I have a linear line, I come over, I click on this point, this portion, and I get to the next point. I've created the point along this vertical segment, and I'll come over to the horizontal because I want to create a reference point. That's the more reason why I'm doing this. Okay, so I'm creating a reference point over here. So I click on this point and make sure my auto is on to make sure that I get end to end of that position. Then from there, I'm now going to get a construction line. Okay, you get a construction line and you introduce a construction line, extend it both vertical and horizontal. So after I might have gotten the vertical horizontal, this is supposed to be our grid line. Okay, this is supposed to get our grid line. Mind you, I said anywhere we need to introduce our beam and our slab and our columns, we need to introduce our grid line, which is what our reference. Okay, so in that situation now, I'm going to take off this, because if I don't take off this, this is going to move and it's going to form as a grid on the structural software. Okay, when you move it down to the structural software, this is what you're going to see on the structural software. So we don't want to have this shorter grid, okay, because this is bearing the grid layer. All right, so we're going to take this off. We're going to take this off. We're going to delete this. All right, then after which we're going to copy and we're going to be pasting this along the wall side. Now this grid for this tutorial, I'll be taking it center to center. In some other video, you can see, you can also make your reference. You can take your grid by side of the wall, either side of the wall, either the front or the other hands of the wall. So in this situation, we'll be taking it from the center of the wall. So now I'll be taking my reference from here, from the side. So in this situation, me taking it from the side, I'm going to be clicking all the portion whereby I'm supposed to have a grid. So I'm going to align the center to center of the wall. So after doing that, so that's why for you to get to this extent, you might have gone through the plan, studied the plan to know where you're going to have your wall and how you're going to throw your slab. So the slab now is designed panel by panel. But for you to design the panel by panel, now we are looking at a situation whereby we are going to design a solid slab. So in some designing a solid slab, this is a situation whereby you have a beam supporting the slab, okay? And we all know how load transmit. The load transmit from the slab down to the beams and from the beam down to the column in a general situation. All right, and from there to the soil structure. So in this situation, we'll be looking at how we can introduce a beam that is going to board. The slab is going to distribute its load down to. So in every situation whereby we're going to create a beam, in creating those beams so that we have a slab. So in doing this, we just have to get this at the vertical area. So you can look at the perimeter, we'll just get it about this area. So we'll look at it in this situation too. We'll click over here, and we'll create all the plan. Now you can see all the vertical beams where I need to insert a column, where I need to insert a beam. The grid has been provided over there. You can see what we have here. Along this wall, I want a beam to be in this wall, because in as much as I'm providing a beam, in as much as I'm providing a beam to take care of this slab that will be introducing, what happens? I want the beam to be embedded into the wall. I want it to be inside the wall. I don't want it to be transparent, right? Because I just want to keep it as simple as possible. So the beam is supposed to be inside the wall. So looking at that situation now, we've gotten all the vertical. So now we want to insert to copy the horizontal grid, and we'll do the same. So we'll just copy and we'll paste the same way we did on the vertical. So you can see over here, I'll be needing a beam along this line. So even over here too, I'll be having a beam here, and I'll be having another beam over here. Here I have a beam, and I'll be needing a beam over here. Okay, so primarily you can see what I'm doing, that I'm just trying to create a grid line over all the segment and all the area where we have where we have to introduce our beam, okay, to beam to take out the slab. And in that situation, I'll be looking at this from panel to panel, okay, and assuming that I'll be having a beam running across this section, and I'll be having a panel over here, and I'll be having a panel crossing all this whole area. Now I'll not be considering this wall, because why? The structural drawing, so it's something we call the load bearing wall and what we call the partition wall. So in some situation, you can look at when you fix the structure and your structure is well supported, some other wall can be considered as it's a partition wall, while some other wall can be considered as what? They can still be considered as what? As a wall bearing load. Okay, so in this situation, this will be our basic wall where we have the grade, and this other beam here, this other wall will be considered as a partition wall that separates between the kitchen and the store as regarded to the architectural drawing, right? So what we are more concerned here is just all about developing a structure, a bone which is going to carry the whole structure, okay, to support the slab, the beam, and the column. So that's what we're trying to do here. So after doing that, we're going to introduce our column. So we'll go back to the layer, and we're going to click on the column. So clicking on the column, now what do? You have to make sure we create the column. Now for you to create this, you need to understand what size of the wall. So you're going to look at what is the size of the wall, because in most situations, as we're looking at, maybe if you're having a commercial building, you can look at how you can support a column. Maybe the size of the column might not really necessary, because we're looking at how to support the whole structure, because most commercial structures are very, very what, versatile, and you know long and whatever you might call it, and very large in size. So when you're looking at it, the square area might be increased. So you're going to increase the wall, the column, to be able to what to carry the soil efficiently. But in this situation, since we are keeping a very small structure, we want to keep it as very small as it should be. So we're going to put all the columns should be hidden into the wall. So I'm providing a column that is going to hide inside the wall. So in this regard, what we're going to do now, we're going to create a column. So I'll create a column by clicking on what? Clicking on the rectangle, right? And mind you, when you click on the column layer, all layers, all should be what? By layer. So over here, I'm going to click here and I'm going to drag down to this area. I can see that's how I've successfully inserted the first column. So at this point, inserting this column, what we need to advise you first of all get all the edges first. All right, first of all get all the edges first before we can do justice to the rest. All right, so in this we're going to click on this and we're going to get the middle and we're going to insert on the edge before we now look at how we're going to support the middle and every other area where necessary. So I'll just be inserting them at where we have the joint. So in this area we'll get it for balancing. All right, so we're going to keep this straight for balancing, and we're going to keep one over here. We're going to have to introduce a column over here, and here we're going to have a slab. So we're going to introduce a slab over here as a cantilever slab to support this structure as it gives. Although this cantilever slab is a bit lengthy on wide, but we're going to take um, care of that when we look at it. So what we're going to do primarily now, just to keep everything at the edge. So sorry, I'm supposed to keep it at the edge, but we're going to do that. But what, mind you, what you need to do is just to keep it safe, just going to get all the edge first. So after getting all the edge, you now look at situation where necessary. You can see that this is part of the edge, and over here we'll be needing a column over here because we're going to have a column to support this beam that is going to receive this slab over here, and we're going to need a beam over here. I'm going to have, sorry, a column, and we need a column over here to support the length of the beam that's crossing over that area. And I think we'll be having another beam here, considering the edge, because when you consider, after considering the edge along the external, we're going to consider some of the edge along the internal. You can see over here we have here, and we can still also decide to run a straight beam over here. All right, so this is just as simple as possible. So if you get this beam over here, we need a column to take care of this load at this point. So we'll be needing a column over here. We'll click the column at this point. So at this point, we'll try to keep this simple as possible. Try to keep everything as simple as possible. So looking at this span, we consider we have a span, and mind you, when we are creating our support, we are looking at how we can range a cantilever, we can range a support setting of 5 meter. We don't want to exceed 5 meter. All right, we don't want to exceed 5 meter. We just want to keep it simple, because reason being that the wider your support, the higher the numbers of reinforcement. All right, the higher the deflection, because when you have kind of a continuous span, or you have the span of your structure spaced apart, then it means you're going to have a high tendency that you'll be having a lot of compression at the bottom area. So we want to keep it as safe, as close as possible. So we don't want to jump at it to get up to 1 meter also. So we want to keep a range of 5 meter, so that we'll be having a moderate detail, because every detailing you're performing here, the support you're creating, all what you're modeling over here is how your analysis is going to come out. So you're going to have a higher reinforcement. So we don't want to have a higher reinforcement on our beam. All right, so we want to keep it simple by adding a kind of adding a lot of support for the beam. Okay, so here we'll be needing a beam over here, so we have to introduce a grid. Okay, that's why I have to copy and I'll paste here. So if we look at this length, what do we have over here? So we'll look at from this other span down to what we have over here. Okay, so I want to check this distance. I want to check this distance. You can see I have 5.5 meter. So I need to introduce a column for the sake of the video. But we can still go above that, design for 6 meters, and the case may be 10 meters, and the case may be, but because of how we're looking at the residential building, we just want to keep it as simple as possible, all right? So that we'll have our reinforcement to be as simple as possible. Maybe single not much reinforcement, all right? So we'll be having a very sweet spacing within the beam reinforcement, because all this we are doing is just to generate to get the load, to understand how the behavior of the structure is going to be, and to get the suitable reinforcement that will enable us design this building effectively. All right, so that's why we need to keep everything simple and everything effective. So over here you can see we have a column here and another column here. We can decide to say, okay, let's leave this column and we'll have a beam support. That is what we can still consider in this direction, or I can still remove this column. Let's say we take this column off, all right? So we can get a beam over here. We'll have it. We're going to introduce a beam here, and we're going to introduce a beam resting on this. So we're going to introduce a primary beam from this column down to this area, and we're going to introduce a secondary support. We'll talk more about that when we get to the design stage. But for now, let's focus on getting the design right. So you can see we have introduced column to where needed in all our support except this region. So what do? We just need to still do the same thing. We'll copy this and we're going to paste them on those area where we need this design. Okay, considering our support of 5 meter. So look at what we have here. So if we've introduced this, we have to take this dimension and look at what do we have here within this grid to this other grid. You can see we have 5.2. 5.2 5.3 is not far from the range, but we can also introduce another one along this bond to keep it safe. All right, and another thing, apart from you just considering 5 meter interval, or considering a particular space in which you're going to introduce your column to support the beam, you're also going to look at what point do I need to introduce for the sake of bonding, because you're going to look at the wall. All right, now you're looking at how the whole structure will be stable, and you're still looking at how do I insert the column such that it's going to marry to double situation, it's going to support the structure well, and it's now going to still what bond suitable to the wall. So we look at what area can we have a column situated such that it's going to bond the wall, are going to bond effectively, and we're going to what situation are we going to look when we are considering our span in between um between the support. Okay, so you can see this area. So let's still consider the span. What do we have here? So we have to be sure by creating our measurement over here. So what do we have? We have 4.6. So we're going to leave that by the way. All right, so in between this column to column, so what do we have? Support to support. All right, we're having 4.2. And let's look at this span. What do we have from this support? Because now when we're supporting our column, we're looking at two things. When you're supporting your beam, we have beam to beam support and we have column to beam support, right? So in this situation now, we'll be having column to column, and we'll be having this span to be beam to column support and beam to beam support. Okay, so in this situation, you can see here we have 4.6. So we are still within the extent of 5 meter, all right? So if you look at this situation, you can see we have 4 meter here, and we're going to have this secondary beam. So this is going to be beam to column, because the beam is moving from this column down to this column. You can see what we have here. From this column, we're going to create a beam over this region. So we're going to create from this column down to this column. And if you look at this situation here now, almost the same thing. So this area, we have a column at this end, and we'll have a beam supporting. So this beam is going to be a secondary beam because it's going to rest on this primary beam. All right, so this is now beam to beam connection. All right, and this is column to column connection. All right, or you can call it beam to beam support and column to column, beam to column and beam to beam connection. And so in that regard, all right, so in this situation we're having beam to column connection and beam to beam connection, although we're having a column at the end. So we're going to leave that. So in this situation, we're going to have this situated, this we're going to throw a beam here that is going to hang over here. All right, so this is how you get a GA. So you can look at the whole structure. So at this time, what we're going to do now, we're going to trim the construction line. All right, going to trim the construction line. So what we do, we have to make sure we introduce the rectangle here, because this rectangle I'm just try to use it to trim the support. So I have to keep it such that it can be measurable, because after now, you're going to throw your dimension out there. So we want to keep it safe. So what do? We have to click on trim, and we're going to trim off the unwanted um, grid. Okay, at this area now, we're going to trim off this whole area. So at this point, you can see what we've gotten. So now we've come to the end of this segment. So you can see what we've done on the ground floor, because we're looking at the ground floor. Okay, so what you're going to do, your GA is going to start from the ground floor. So after you might have started the GA from the ground floor, you will now look at the first floor. Okay, you now look at how you can going to superimpose the first floor. But in this condition, if you look at it, what we have in this beam, what you have here is the same thing you have over here. Okay, what you have over here is the same thing. So if you want to do that, just to check, what you need to do is just to copy this beam. Please always copy for reference. All right, so we're going to copy this, and we're going to do what? We're going to space it out. So after that, we're not going to what? We're not going to highlight this. I just copy this so that I will get a spare of that. Okay, so after I might have done that, I'll just highlight everything from the first floor. Then I'm going to color it. I'm going to change the color over here. I'm going to change its color. I just want to change the color. Maybe I'll change the color to since I have green, maybe I'm going to change it to yellow so as to be transparent. Let's change everything to yellow. So after changing it to yellow, I'm going to introduce block. I want to block it so that I can be able to carry it from one point to the other. It will be a combined um, settings, not just one. You can see if I click on one, they are all bound together. So with this, I'm going to copy this, or move it rather. So we're going to take a reference. You can see the reference. Please always take your reference from your staircase. Okay, always take your reference from your staircase. So at this point, we'll take our reference to this staircase, and we'll place it where we have it at the staircase. You can see it's as if it's moving. So we are going to click it back, and we move from this point down to the point. So you can see everything is as full as it is. So what we have on the ground floor is the same thing as what we have on the upper floor. But in a situation whereby what you have on the first floor is different from what you have on the first floor, what you need to do is you need to do what? You need introduce your column and consider the solution. In our other video, we'll be considering such situation whereby we'll have a kind of a little difference from what you have on the first floor to what you have on the second floor. So for the sake of this video, we'll just keep it simple. But every other video, we'll be talking about that. So in that situation now, let's move this, because we've already did our confirmation. So we can take this off. All right. So this is what and how you can get your GA done. And mind you, you're going to still consider how did you get here. We'll get here by doing what? Looking at all this drawing panel by panel, because we're going to look at how do you support your slab. That is how you know where you need to introduce your beam. You don't just begin to provide beam. Okay, we're going to look at where do I need to introduce my slab. All right, because if I'm having a void situation, if I'm having a void, like you're having a staircase here, I cannot introduce my slab over here, right? So I'm going to introduce my slab where I know that what I'm going to be having what I'm going to be having I'm going to be having what? I'm going to be having my slab, okay? So where I need my slab is where I'm going to introduce my beam, because the slab is supposed to rest. Because mind you, like I said, we are talking about what? Our solid slab, okay? Solid slab where we introduce a beam to carry the weight of the slab, so that the stress and the stress is going to be distributed. The load is going to be distributed down to the beam, and from the beam down to the column. So you can see at this point now, we are going to introduce what? We are going to introduce a slab, because when you navigate from the staircase down to the landing, and the landing down to the first floor, this is where you're going to what? You're going to land. So the whole of this um, segment, this panel is not going to be void. We're just going to what? We're going to introduce our slab from this unit. So if that be the reason, we can still take this and what? We're going to copy this, and we're going to shift this other grid down to somewhere here. Reason being that all this area will be needing what? Going to provide our grid. And mind you, we're providing our grid where we need our structural elements such as the slab, the beam, the column, the walls, and every other thing needed. Okay, so where we need to introduce our structural element, we need to provide our grid. So you can see we achieve by achieve our GA, which is the first step, what you need to understand when you're carrying out your structural drawing by a general arrangement, which consists of how you analyze where you arrange your beam according to how the structure is going to be, where you're going to have your slab, your beam, and your column. So you can see all this area where we need our slab, we introduce our beam as due, and where we need our column to support the stress of generated from the building, all the other load, everything has been put into place. Okay, so at this point now you can see that we've come to the level, we've finished our GA. So now we'll be moving on to we'll be exporting this down to the product structure, or in your own situation whereby if you have every other structural software that you use, then it is due for you to, you know what, to use it to do. So at this point, well, I'm now going to move this out, and I'm going to what, save it so that I can be what, to export it down to product structure. So how do I do that? I'm going to highlight this. I'm going to align this. And mind you, before I do that, you can also generate your beam. You can also create a beam panel here, okay? You can also create a beam panel. You can also create a slab panel. So when you move to AutoCAD, everything will just take its place and take its form. I'll be doing a video on that, how you can do that as simple as possible, okay? But for the sake of this video, let's just keep it simple. So I just want to generate my grid line and my color line, and I'll take in that. So for me to do that, I'll just highlight all the structure, then I'll just do a copyright block. That is to save as, okay? But in this situation, I'm just saving a particular drawing, because if you do save as, maybe it's going to save all the drawing in that particular template. So I'm just trying to take it and just to save that particular drawing. So that's what I use, right block to save it, by clicking or by highlighting the whole structure that I want to save, that particular structure, or the structure that you want to export out. You are going to highlight that particular structure, then you're going to do what, W, enter, then, or you do your type right, your right block, and you can see the insert unit millimeter, right? So this millimeter, this unit is going to be as you want your to set, as the drawing template has to be set, okay? Or how you want it, you prefer it to be. So with that, we're going to click that little bulb along that line. So we're going to save it. So in this situation, we'll be saving it in the desktop or any document, anywhere I want to save it, such that we can easily get it. So in this scenario, let's just place it in what? Sorry, let's just click it at the document. So if I click on the document, then I'm going to what? Name it. Maybe I'm going to say, let's just call it a sample. Let's just name this file a sample, maybe sample tutor. Okay. Okay, if this is what we name it, then we're going to look at what, because we have a different file format. You can see DWG is your AutoCAD format, and if you look at your DSF is referred to what, to your, maybe if you want to save to every other export file bearing this file name. Okay, like product structure, we have DSF, and there's some other folders where you save to DSF. All right, so we're going to pick any of this. Any of these here is going to work. So let's go with 2010. If you click 2010, then we'll click on save. Then after that, we'll click OK. So we're going to see something popping up here. After that, then you know that you've already saved it. All right. But in some cases, when you have a large file, you have to wait for it to be able to load. So we've come to the end of the GA. So when I'll be going to the step 2, where we're going to do our model, and where we're going to do other structural model, we're going to take care of our hinging and every other formula, how to insert our wall and how to insert our load.